Okay, so question 5 is all about radiation intensity to start with, and then the greenhouse effect in the later part. So you're given a table of data, which almost certainly means you're going to need to use it, and it says the solar constant is the energy received from the sun each second by a square metre of surface, and the question is about absorption of the sun's energy by planets. The table below shows how the solar constant depends on the distance from the sun. So unsurprisingly, as we get further away from the sun, each square metre of surface absorbs less energy per second. So you've got joules per second there, that's the energy per second absorbed, and the per square metre bit is for each metre squared of surface area. Okay, so here are 4 properties of electromagnetic radiation. One of these is the same as the solar constant. Which one? Now, this seems like a really bizarre question. If you get a question like this and you're not really sure which one is the same as the solar constant, then the thing to look at is the units here. What are the units of the solar constant? Because if something's going to be the same as the solar constant, it must have the same units. Here, a really important thing is a process of elimination. Hopefully you should remember that the unit of frequency is hertz, and that's not hertz, so it can't be frequency. The unit of speed is meters per second, so that, not meters per second, certainly, it can't be speed. And the unit of photon energy, well, energy usually measured in joules, and that's joules but with some extra stuff on the end. So just by a process of elimination, even if you can't remember that intensity is energy per second per metre squared, which is quite a tricky unit, then that's the only one that will fit. So again, this process of elimination is important here, and it is in fact intensity. So, the planet Mars is about 250 million kilometres from the Sun. Use the data in the table to estimate the solar constant at Mars. Put a tick in the box next to the best estimate. So, when we look at the table, it only goes up to 150 million kilometres from the Sun. So, Mars is further away than that. So, immediately, you should be able to narrow it down to 2, because if it's further away, it's got to be less than 1400. So the bottom 2 options, the 4000 and the 8000, no chance. The question then is, which of these 2 is it? Well, for that you have to look at how quickly it's going down. Going from 125 to 150, it's gone down by 600. So it would seem to be fairly likely that it's going to get past 1000, right? Even just using that simple reasoning, that suggests the answer 500. If you're really watching carefully, you'll be able to see the pattern that when we double the distance, right, from the Sun, the solar constant goes down by a factor of 4 here. We go down from 12,000 to 3,000 for double the distance. And that's something you may have learned about called the inverse square law. If you haven't learned about that, you don't necessarily need to know it. But if you have, then it's helpful to see this. It's more likely triple students will have learned about that. So if we use that idea, then 250 is double 125, so we'd expect, again, the solar constant to fall by a factor of 4 when we double the 125 to make 250. And indeed, if you look at the options, we've got 2000 divided by 4 is 500, so that's definitely the right one. But you don't really need the inverse square law to see that. You can tell that as it's going down, by the time it gets to 250, it's definitely going to be less than 1000. And finally, the Earth and our Moon are both 150 million kilometres from the Sun. The following statements are all true, so it tells you, so we can't use this idea of untrue statements to get rid of them, okay? But only one of them correctly explains why the Moon receives less energy than the Earth. Very often when you see these things with 4 true statements, students will often read the first one and realise that it's true and just tick that one. That's not what it's asking. Which statement explains why the Moon receives less energy than the Earth? Okay, so the Earth has an atmosphere that the Moon does not. Well, if anything, that would make the Earth receive less energy because the atmosphere is going to absorb some of the radiation. So there can't be that one. The Earth rotates once a day while the Moon rotates once a month. Well, it shouldn't make any difference the amount of rotation that's going on. The Earth and the Moon are still there. They're still the same distance away from the Sun, so that seems unlikely. The Moon has a much smaller surface area than the Earth. Well, that makes sense, right? If the Moon's got a smaller area, then there's going to be less energy hitting it, so it's going to absorb less. The Moon is all rocky while the Earth has oceans. Well, again, you might expect then that you get more reflection from the Earth, which would reduce the amount that the Earth absorbs. And indeed that is true, but the biggest factor by far is the size of the Moon being much smaller. So because the Moon is smaller, it will absorb less energy. It's that box. Right, 6-mark question now. And it's a 6-mark question with a data table. Okay, and some information also, some numerical information in the text. If you ever get a 6-mark question in the data table, with a data table, at the bare minimum, you're going to need to be comparing the data in the table, and you may need to be doing some sort of calculation as well. Okay. Now this is a tough 6-mark question because in the mark scheme it says here this question is targeted at grades up to A star. What that means is that if you're getting 3 or 4 on this, you're doing pretty well. Okay. So even if you're not quite going to get 5 or 6, then if you can manage to get into 3 or 4, the level 2 section here, then that's going to be really good. Okay, let's look at the question then. So Venus is closer to the Sun than the Earth, but is very much hotter than you would expect for a planet in its position. It has a mean surface temperature of 460 degrees centigrade, which is hot enough to melt zinc. The mean surface temperature of the Earth is 15 degrees centigrade. The atmospheres of the 2 planets are very different, so there's some data which we'll look at in detail in a second about the different gases found in the atmosphere of the 2 planets. Using the data provided, explain the processes which have produced the difference in temperatures between Venus and the Earth and why there are concerns about the future of the Earth. So, with these 6-mark questions, what often happens is that people will only answer the first part. You need to make sure when you're thinking about this that you need to do the explaining the processes, and they've not told you what that process is, so we've got to work that out first. Produce the difference in temperature between the Venus and the Earth. So we're talking about a difference between Venus and Earth in temperature that's going to have to be explained by a difference between the numbers in this table. And then the last part, which is often the bit that gets left out, and why there are concerns about the future of the Earth. Well, that whole thing is signposting. Temperature and atmosphere is signposting global warming and the greenhouse effect. Okay, so you need to make sure that you can explain the greenhouse effect. Now, I'm not going to go into a detailed explanation of the greenhouse effect here. Just you need to look in your revision guide if you're not sure. But if you look on the points relevant to the greenhouse effect here, so the first thing to do here is explain the process. So just a general explanation of what the greenhouse effect is first, before you do the comparison. So, what the basic idea is that the greenhouse gases transmit, so they let through the radiation coming directly from the sun, but they absorb the infrared radiation that's given out by the planet that's been warmed by the sun's rays. And that results in absorption in the atmosphere, and the planet stays warmer because it's trapping the energy that would otherwise be radiated out into space, that this infrared radiation coming from the warm planet. Okay, so that's the explanation of the greenhouse effect. The second thing to do is to identify which gases are important in the greenhouse effect. Now, if you're ever unsure about which gases are important in the greenhouse effect, any gases that have got 2 different atoms in them will, in some different types of atom, will in some way contribute to the greenhouse effect. So, in this list, that's sulfur dioxide, it's got which is SO2, water vapour, obviously H2O, and carbon dioxide, CO2. The argon goes around as single atoms, so that doesn't matter. And the nitrogen and the oxygen, N2 and O2, are made up of a single type of atom, so they're not really greenhouse gases. You should learn the list of greenhouse gases, but it's useful to be able to identify the ones that have different atoms in them will contribute, okay, because they are able to absorb the infrared. So that's another point we can make there, is to identify what the greenhouse gases are. Okay, and then we need to make a comparison between the 2 atmospheres for each greenhouse gas. So Venus has massively more carbon dioxide than Earth, and carbon dioxide is obviously the greenhouse gas that gets the most publicity on Earth because of the fact that it's produced via human activity, burning fossil fuels and things like that. Okay, you should note that the amount of water vapour on Venus is much less, so that contribution will be smaller. But if you look at it's only about 1% on Earth, and it's a tiny fraction of a percent on Venus, that's probably not significant. Certainly not as significant as the huge difference in carbon dioxide up here. And again, the sulfur dioxide, negligible just means that there's so little that it's very difficult to measure it on this scale, so it's going to be even less than this sort of 0.002 that we've got here for the Venus water vapour. And there's only a very small amount on Venus as well. It's important to note those 2, even though they're not the biggest difference. So the massively biggest difference comes from the carbon dioxide. So if we look at the levelling on here, For a level 1 to 2 answer, you need to explain something about how the greenhouse effect works, and probably to recognise carbon dioxide is important there, and that it's most of Venus's atmosphere. The better answer, right, will include this idea of frequency differences, so the idea that the radiation coming from the sun is high energy photons or high frequency photons, and that the radiation emitted by the planet is infrared, and that's why it gets trapped, because it's a different energy to the radiation that's coming in. Okay? And the idea also that in this last part of the question, why are there concerns about the future of the Earth, that clearly Venus is an example of what happens if we have what we call a runaway greenhouse effect. So much carbon dioxide in the atmosphere that the temperature just shoots up ridiculously. Okay, ridiculously higher than it would be without the carbon dioxide there. And finally, for the level 5 to 6 answer, you will need also to recognise not just the carbon dioxide differences, but to comment on these water vapour and sulphur dioxide differences. So really, everyone should be able to get into the level 3 to into the level 2, the 3 to 4 mark box here. Okay, because a good understanding of how global warming works, which you should all learn how the greenhouse effect works, and remember, global warming is just too much of the greenhouse effect caused by higher than normal levels of these greenhouse gases. Okay, there's no reason that we can't get into that box. Okay, spotting the other 2 greenhouse gases, well, you may or may not do that, but remember, if we can get 4 marks in a 6 mark question, we're doing very well.